The important topic in memory management known as segmentation, right? So the segmentation is an example of the non-contiguous memory allocation, right? So I told you the difference between the contiguous and non-contiguous, where the allocation of the process which is done in a sequential order, in the continuous order, is called as contiguous. And any process which is not stored in a continuous manner or not stored in a sequential order, that type of this thing is known as non-contiguous. Allocation which is not done in a sequential order is called as non-contiguous, and the example of non-contiguous memory allocation is the segmentation, right? So now let us define what do you mean by the segmentation. As we know, this is a non-contiguous memory allocations where we are dividing the memory into a different parts or different sections of variable size parts, right? Any memory which is divided into a different sections of varied size. It's not fixed as in case of our paging where the memory was divided into a fixed size of partition, what we term it as pages over there, right? In segmentation, what do we do here? The memory is divided into a different parts or different sections. These particular sections is of the varying size. It differs with respect to one section is of 10 KB, another section may be of 20 KB. It means that each and every sections which is divided in the memory is of variable size known as segments. Got it? This is what the definition of this segmentation, where each of these parts is known as segment and which can be allocated to the process. Fine? And here we are saying that each and every section which is divided known as a segment, and each and every segment consisting of two informations, right? Which are those? Each segment has the name as well as the length, right? It means that each and every section that we are dividing consisting of name which is indicating the segment number, right? And another section of the segment which is indicating length. What does that length specify? The size of the segment. Is that clear? Each and every section which is divided consisting of two parts. One is representing the segment number, another one is representing for the length. What is that purpose? Segment number means what? Number is normally used for the unique identification, right? As a student is having a register number or the roll number, what for? It is for the unique identification of the student. Whereas in case of my process, what do I do? A segment number is given, so that which if I say it as simply as P1, P2, P3, each and every process has got unique number, right? It cannot overlap with this and this and this. If I say generally the process, how to differentiate between one process to other process? That's why we are representing with the help of a name known as segment number, right? And when the segment number is given, how much size of that particular process it should be, right? That size is nothing but the length of that particular process, right? The length of that particular process that we are defining. And the next point, we have said that the details about each and every segment, right? The details of this each and every segment number and the segment length is being stored under the table known as segment table, right? Where each and every information stored under this segment consisting of two informations, all these things have been stored under which table known as segment table. That's what I have clearly defined in the figure, right? And next point, and segment table we got to know. Our segment table just consists of this information about what all the segment is holding up, right? Next point, segment table consists of mainly two informations, right? A segment table consists of two informations. Which are those two information? One is called as base, another one is limit. It is also very simple. Base indicating the beginning of the address or the base address of that which particular segment, which particular sections that we are defining. That is what the base. And what is this limit specifying? The size or the length of the each and every segment. Is that clear? Fine. Now let us go with the next point, where we are going to translation of this logical address into physical address by the segment table. What does this meaning? What is the meaning of this statement? Where we are going to map between logical address to physical addresses with the help of a segment table. What the meaning of it? How do we map it here? Here we have given a mapping. Here this is the logical address, there is a physical address, in between we have a segment table. This is our logical part, this is our physical part, right? And here both the things have been connected with a central point, what it is? A segment table, right? So this is what the point that is explaining all about. And the next point is CPU generates the logical address which contains two parts. As I told you, CPU generates the logical address, right? Which are the logical address that it is holding here? One is segment number, another one is offset, or else you can say offset or the displacement. These are the two information that the CPU is going to hold up, right? A CPU is holding two information. Which are those? One is segment number, another one is offset. You can say either offset or else a displacement. In short, we can write it as D. Got the meaning? Fine. After this, I have been keep on saying the segment number, segment number, segment number. What is that segment number? It is nothing but it is a unique identification. What we have termed here, right? Here, segment number is mapped to the segment table. Segment number is mapped to the segment table, and the limit of this respective segment is compared with the offset. What the meaning of it? Where segment number is mapped to the segment table. Here is the segment number. What is the 5 by 0, 1, 2, 3, so on. We don't know how many number of the process that we have stored. This segment number is mapped to the segment table, and the limit of this respective segment is compared with the offset. What the meaning of it? This segment number is mapped to this segment table, and the respective limit is mapped to the offset. This is what the meaning of this particular point. And next point, if offset is less than that of the limit, if the offset is less than that of the limit, then it is said to be as a valid statement, right? I told you, I have taken an example like if the base address was, in our paging technology also we are explaining. Always the base address and the limit address we are comparing, and then we are mapping with the help of this relocation register, right? Here also similarly, if offset is less than that of the limit value, then we say the condition becomes true, then we allocate that things into the physical memory. If it is false, if it is not true, if offset is greater than that of the limit, what we say? There is an error occurring. We say it as a trap or else an error has occurred. If error has occurred means it is not possible for us to store that process into our memory. Is that clear? This is what that point is indicating. If offset is less than the limit of the address, then we say it is valid. Else it throws an error message that you cannot store that process into a physical memory. Okay? And then in case if it is true, what do we do? In case if it is a valid address, if the condition becomes true, of the segment, then it is added to the offset. If the condition becomes true, then only it is added to this base address. That's why here we are pointing out and adding up. Plus sign indicates adding up of the number. Adding up of that address into the actual word in the memory. Once we add up the things and it is stored into a physical memory. Fine.